right, we just finished a great game, factoring. Basically, what you guys were just doing, we're factoring. Okay, you didn't even know you were factoring, but that's what you were doing. All right, and what we're about to do is all of the hard problems in the game are exactly what we're going to do to factor. Okay, so we're going to take a look at factoring quadratic trinomials. Now, what's a quadratic trinomial? It has to have a power of 2, and there has to be 3 terms. So we're factoring quadratic trinomials, all right? So here's the first one that we're going to factor together. It's going to look like this. It's going to be x squared. It's going to be x squared plus 8x plus 15. Okay? So this is a quadratic trinomial. Notice there's no equation. There's nothing to solve. Okay, what we're doing is we're factoring, right? And remember the other day I told you that factoring was unmultiplying. Well, we're going to solve a factoring quadratic trinomial problem the exact same way that we just played the game. And I call this the diamond method. Okay, kind of like makes a diamond, right? Or the X method. Now, what you do, here's what you do. It's very, very straightforward. It's just like the game. You take the number at the end, the C. Right, remember this is representative of the C when I'm talking about the C there. Oh, I just kind of went away. That's a bad color. The C. So you take the C, you put that number in the top of your diamond, just like this. The B, you put the number at the bottom, and you play the game with yourself. It's the exact same game that we just played. So what two numbers multiply to 15 at the same time add to 8? Okay, 5 and 3. Okay, so everyone agrees that the answer should be 5 and a 3. Does it matter where I put them? No. Okay, now, remember, keep in mind that we have this algebraic theorem that says there is a unique, which means there's only one way to factor this, okay? So now, what do you do with these numbers? That's the whole point, okay? What do you do with these numbers, right? Well, here's what you do. Watch this. Remember that box method I was telling you about the other day? Okay, I love the box method. So many applications, right? Well, watch this. I'm just going to make up a binomial. I'm going to make up another binomial. What are the 2 binomials I made up? Read them to me. X plus 5 and x plus 3. I'm going to do the box method really quick here, okay? Just help me out. So this is x squared, this is a 5x, this is a 3x, and this is a 15. Well, that simplifies to x squared plus 8x plus 15. Well, hey, wait a minute. That's exactly what that is. Are you guys seeing this connection here? Okay. So the story goes like this. If you are given a quadratic trinomial, which is what this is, it can be factored into the product of 2 binomials. And the answer to the way you factor it are the numbers on the side of the game that you play. Okay? So I'll say that again. The quadratic trinomial can be factored into a product, meaning a number times a number, of 2 linear binomials. Does that make sense? Oh, that's a lot of words there in that sentence, okay? A quadratic trinomial can be factored into the product of 2 linear binomials. There's a lot going on there. But if you understand that language, then that puts you farther ahead than most Algebra 1 students who don't even know what I'm talking about when I say those words. Do you guys understand all of those words I just said? Okay, so that's the goal of this. That's where we're going with this, right? And the way that we do it is by playing that diamond game that we just finished in class together, okay? You see the connection between everything here? Right. Okay, we want to factor this. Now remember, I just finished saying that a quadratic trinomial can be factored into the product of 2 linear binomials. And the way that we do it is we play the game. So I put 24 on the top, I do negative 11 down there. What's the question right now that you're asking to yourselves internally? What's the question you're going to say? What? Good. Good. He just said, what times what is 24, and at the same time, what plus what is negative 11. Anybody got any thoughts?
Yeah.
What do you got for me? -8 and -3. how do you go about finding that? Is it better to figure out the product first or the sum first? The product is better to figure out the product first, right? What times what is 24? That'll help you out. Okay, so we think it's -8. Let's check. -8 times the -3, that's positive 24. And then -8 minus the 3 again is -11. Great. So how do I write that out in my answer? We say that this is x minus 8 and x minus 3. And that's it. Now, could you have also written this and gotten the problem correct? X minus 3 times x minus 8. Is that also allowed? Yes, it sure is. This is allowed and this is allowed. Remember, it's a product. I want you to start thinking about this binomial, everything I've highlighted in blue, as a number. Okay? Because x is a variable, so it replaces another number, right? So if I tell you what x is, then everything in that blue becomes a number. So what you have is a number times a number, this whole thing. So you have the product of two numbers. And they are linear binomials. You guys hanging in there with? Okay, I've got x squared plus 2x minus 15. This is a quadratic trinomial. I would like to factor this. Okay, so I know that this can be factored, if it can be factored at all, right, into the product of two linear binomials. So I'm going to play the game here. So what number goes on the top? No, not 15. Negative 15. That's the number that goes on top. That's the C value, right? What number goes on the bottom? 2. Very good. Who's got it? What two numbers multiply to 15?
5 and -3.
Yeah, I know 5 and 3 do, right? So the way that I do this, right? I just look at the number and I disregard the sign. I'm trying to get 15. Well, the only way I can get to 15 is 1 times 15 or 5 times 3. So I just put a 5 and a 3 down. Okay? Now I know I need to make negative 15, but I also need to keep positive 2, so the smaller one has to be the negative one. That's how I do it. Right? Does that make sense?
Yes.
Okay, so then I know the answer has to be 5, or x plus 5, excuse me, and then x minus 3. Okay, try these two on your own right now. I gave you n's and c's, but it works the same way. Okay, Flavia, what'd you come up with for part A?
I got n plus 12 and minus 3.
So you got 12 and a negative 3, right? So that would give you an n plus 12 and then an n minus 3. Who agrees? Pull out your hands up. Show me what you got. Everybody agrees? Jay, you agree, buddy? N plus 12 and minus 3? Okay, good. Evan, did you get B yet, buddy?
Yeah.
Yeah, okay. What'd you get for B?
I got n minus 7.
So you got a negative 7
Yeah.
and what?
And then n plus 3.
Positive 3? Okay. So is that right? So negative 7 times 3. Yep, that looks like it's good to me. So I have n minus 7 times an n plus 3. Hands up if you agree. Let the record show everyone in the room has hands up. Okay, good. What? Bonus box. Wait a minute. Time out. Time out. Time out. Why is there a y in there? We're trying to factor a trinomial with two different variables. See if you can do it. Okay, you guys want to talk about this one? Let's talk about this one. So check it out. We're gonna make our chart again, right? What goes in the top? Negative 55. What's the bottom? 6, right? Okay. What two numbers can make this work? So an 11 and a 5, right? So I need to make that one has to be the smaller one, okay? So if I was just doing this normally, I'd have an x here, I would have an x here, right? And the numbers I would use would be positive 11 and negative 5. But all you gotta do is add the y there. And there's your answer. Right? There's your answer. Because 11y, now watch, this does work because if I did the box method, right? If I did x plus 11y and I multiply that with x minus 5y, look what we're going to get. We're going to get x squared. We're going to get 11xy. We're going to get negative 5xy. And we're going to get negative 55y squared. If I add those together, look what I get. There's my positive 6xy. So it can be done with two variables as well.